Now we're in business. On Wednesday, we'll go over 3.7, and that homework, y'all, will be due by next Wednesday. Okay, so just give me a heads up. The notes are right here. Okay, so let me see. I put my notes already here, y'all. I already uploaded them to my OneNote, so we can start going through this stuff. And so what we're doing today, y'all, we're talking about something called the chain rule. Okay, so we use the chain rule, y'all, when we have something called the composition of two functions. So instead of us looking at, say, like, I don't know, f of x equals x to the third, we might look at f of x equals x squared plus 5x minus 3, all of that raised to the third. And the question is, how do we take the derivative of that as instead of it's just like instead of x cubed, it's a whole polynomial. Bless you. It's a whole polynomial being cubed. Okay. So let me get some water real quick, y'all. Okay. So for 3.6, what we're going to do the chain rule for the composition of two functions. Hello. We're going to apply the chain rule together with the power rule. We'll do the chain rule with the product and quotient rules. And let's see, recognize the chain rule for a composition of three or more functions. We're not really going to go through the proof of it, y'all, but we're going to go through some of these things here. Okay, so let me zoom in a little bit so y'all can see a little bit better. So here we go, the chain rule. So it says, let f and g be functions for all x in the domain of g, for which g is differentiable at x and f is differentiable at g of x. The derivative of the composition of two functions. So we have a new function h of x. H of x is defined as f of g of x. Okay, so again, just to give you an example, what do I mean by this? If I were to have a function that would look something like this, x squared plus 5x plus 6, everything is being raised to the third. So again, maybe you remember this from college algebra, maybe you don't. But the idea is we have a composition of functions. Instead of just looking at x to the third, we're looking at all of this being raised to the third. So, excuse me, we're evaluating a function as a function, okay? So the way we take the derivative, y'all, is we take the derivative of the outside function. In this case, my outside function would be the cube function evaluated at what we have here, and then we have to take the derivative of what we call the inside function. Okay, we're going to go through some examples because I know talking about outside function and inside function and taking the derivative, I know it gets a little confusing, but we're going to go through some of this stuff. Okay. All right. So problem solving strategy for applying the chain rule. It says to differentiate h of x equals f of g of x, we want to identify f of x and g of x. F of x, y'all, is what I call my outside function, and g of x is what I call the inside function, okay? And it says find f prime of x, so we're taking the derivative of the outside, evaluate it at g of x to find this part. Then we're going to find g prime of x, which is the derivative of the inside, and then this is how we're going to write our answer, okay? So look, we're going to go through a problem so that we kind of hopefully understand what's going on here, okay? So let me scroll a little bit here, and here we go. Okay, so here's my function. It says f of x equals x squared plus 3x plus 8. And all of that is being raised to the third power, okay? We want to find the derivative of this, okay? So y'all, just because of the notation that they were using earlier, I'm going to call this h of x, and we're going to find h prime, and then we're going to find, h prime at, what number would they use here? At 2, okay? Just so that I can use that kind of same notation, okay? So one of the strategies says we want to find the outside function, and we want to find the inside function. To me, the inside function is really easy to do because look what's inside those parentheses. It's that easy. It really that easy? Yep, that easy. Look, this is my inside function. X squared plus 3x plus 8. My outside function is the third power. Well, what to the third power? X to the third power. Okay. Because if I were to find this, if I were to find f of g of x, do you agree that I would take this part right here? Wouldn't I plug that into that part? And then wouldn't I end up with the original function that we have? Okay. So the way we do this, y'all, the first thing we're going to do, we want to take the derivative of the part that has the third. So remember how we take the derivative of the part that has the third? We put 3. Okay. Now, because this is the inside function, that's going to stay as it is. Okay. What do we do with these powers here? Once we bring down the power, what do we do with that power? We subtract it by a power of 1, right? Okay. Then what we need to do, y'all, is we have to take the derivative of the inside. What I mean by the inside, we have to take the derivative of the stuff that was inside that part there. So we're going to do this piece at a time. What's the derivative of x squared? 2x. What's the derivative of 3x? 3. What's the derivative of 8? Okay. Right here, y'all, this is our answer. That whole thing, 3x squared plus 3x plus 8 times, or squared, times 2x plus 3. Okay. This is called the chain rule. We're taking the derivative, but we also have to take the derivative of what's inside those parentheses. Okay. Before we go on, are we okay in how we got to where we are? We're good? Okay, yeah. Those of you guys that are watching online, are we good on how we got to that part, y'all? Just want to make sure that we're okay here. So let's see. Julio,
Yeah,
Linda,
yes, I'm good, sir.
Gabriela, we good?
We're good.
Let me see. Yeah. I'm gonna raise up my volume a little bit and make sure my volume here is on. Matias, can you say something? I just want to make sure you were good.
Yeah, I'm good, sir.
Okay, just checking. Okay, I can hear you now. I couldn't hear you earlier. I want to make sure we're okay. Okay, so let me go ahead and go back. Now, look at the next part, y'all. We're going to find h prime at 2. So what does that mean we're going to do? Everywhere we have an x, we're going to plug in a. Okay, let's do it to it. So 3, and then 2 squared, plus 3 times 2, plus 8. All of that's being squared, times 2 times 2, plus 3. Okay, so we just got to do a little algebra here, y'all. A little evaluating. Okay, so let's do the inside here first. 2 squared is 4. 3 and 2 is 6. And that's a plus 8 squared. And then 2 times 2 is 4 plus 3. So h prime at 2 is going to be 3 times, let's see, 4 plus 6 plus 8. Everybody agree that's going to give me 18. Excellent. Squared. And that's 7. Okay. So I'm just going to do my calculator here, y'all. I got to figure out at least what's 18 squared. Say that. Okay. 18 squared. 324 times 3. Oops. 324 times 3 times 7. And I'm coming up with 6,804. Okay. And we got it. Okay. So again, I'm doing the chain rule here. I'm taking the derivative of the big function, which is kind of like the outside function, and then I have to take the derivative of what's inside all that movement too. Okay. All right. So let's try this next one here, y'all. And we're going to use the chain and the power rule. Okay, so we have a couple of options. I'm doing this particular problem here. I guess if I was sitting where you're sitting, the first thing I might do is say, look, why don't I rewrite this as 3x squared plus 1? If I wanted to bring this expression up to the top, what would happen to my power? Anybody remember? -2. Excellent. Perfect. Okay, so now we're going to go ahead and start finding our derivative. Okay. So remember, to find the derivative, that power is going to come down to the front. Okay. And we have to subtract 1 from that. So -2 minus 1 actually becomes a -3. And then we have to take the derivative of what's inside there. So anybody know what's the derivative of 3x squared? Good. What about the derivative of 1? Okay, so we don't need to do anything with it? All right, now y'all, we're going to just clean up this mess a little bit. Okay. Let's multiply this -2 and that 6x together. Everybody agree that would give me a -12x? And then if I were to take this guy right here and bring him back down to the bottom, would y'all agree with me that that would give me a 3x squared plus 1 all raised to the third? Okay. And there's our derivative. Okay. Guys, just to give you a heads up, if you want to, we could have used the quotient rule here. We could have said the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. We still would have ended up with that same expression. Okay, we still would have had the same thing. Tell me, John. Because we multiplied this one and this one together? And we left them, remember, I can think of everything as being over 1, right? So it's already on the top, and because this one here has the power of -3, pick it down, it becomes power of +3. We're good? Good. All right. So take a look at the next one here, y'all. This one says using the chain rule and power rules with a Trig function. Okay, so we're going to do the same thing here. Now, the only thing I want to do here, y'all, I'm going to rewrite this part. I want y'all to understand that sine cubed x really means sine x. All of that is being raised to the third power. That and this really mean the same thing. When the cube is on the trig function itself, whether it's on the sine or the cosine, the function itself is being cubed. Okay, it's not sine of x to the third, it's sine cubed to the third, and it really means the sine function is being cubed. Okay, so now look, if we were to find the derivative, we're going to do the same thing. We're going to bring the 3 down to the front. We're going to subtract this power by 1. That's going to give me 2. And then I'm going to ask you all a question. You got to take the derivative of what's inside. We did this on Wednesday last week. Yeah, remember the derivative of sine was, what did you say, John? Cosine x. Okay. Now, the only thing I'm going to do here, y'all, yeah. And that's all I'm going to do. Again, I just really wanted to emphasize that when my power is on the outside, the power is on the trig function itself. Okay. Now we can't factor out the x number because the trig functions are, it's a function of the angle, right? So I can't state the angle. All right. So let's take a look at the next one here. It says finding the equation of a tangent line. So we want to find the equation of a line tangent to the graph h of x equals 1 over 3x minus 5 all squared at x equals 2. Okay, so y'all, we've done, we haven't done this particular problem, but we have found equations of tangent lines before, right? Okay, so the first thing we're going to do, y'all, we know that our x value is 2, Before I even take the derivative, I want to find my y value of the function. So I'm going to find f of 2. Okay, we're going to take the derivative as well, but I'm going to come back over here so we can find what the y value is. Okay, so 3 times 2 is 6. 6 minus 5 is how much? 1. And 1 squared is still? Okay. So we know that f of 2 is equal to 1, right? Because 1 squared divided, or 1 divided by 1 squared is still going to give me 1, right? Okay, so all that means, just to give you a heads up, y'all, is that my y value is also, I'm sorry, it's 1, not 2. There we go. Okay, so now let's go ahead and find our derivative. We're going to find h prime of x. Okay, so y'all, I can do this like we did earlier. I would probably rewrite it so that it looks like this, and then use my power rule, right? So I would probably rewrite the function so that I have that, instead of 1 over 3x minus 5 squared, I have it as 3x minus 5 to the power negative 2. Remember, we bring down the negative 2, 3x minus 5. What's the power on this now? Guess again. Negative 3. Excellent. Good. Okay. And then we have to take the derivative of what's inside. So we're going to take the derivative of what's inside there. So the derivative of 3x is just 3, and the derivative of 5 was 0, so we don't need it, okay? So now look, h prime of x, just like we did with the other problem, y'all. I'm going to take these two numbers and put them together. So remember, we're still multiplying. So negative 2 and positive 3 should leave me with a negative 6 all over 3x minus 5. Everybody agree to the third? Okay. Now, if we're going to find, remember, we're finding the slope right now, right? Because we're taking the derivative's going to come in the slope. Since we want to do this at x is equal to 2, we're going to find h prime at 2. So negative 6, 3 times 2 minus 5 thirds. That'll be negative 6. 3 times 2 is 6. Minus 5 to the third, that's negative 6. 6 minus 5 is 1 to the third, and 1 to the third is still 1, right? So our slope when x equals 2 is negative 6, okay? So we found our m, right? This is my slope of the tangent line. Remember, y'all, here's the point that we have. When x is 2, y is equal to 1. Okay? So all I'm going to do right here, y'all, I'm going to write down my equation. Y minus y1 equals m x minus x1. And I'm just going to plug my numbers in. So y minus, the y value we had was 1, equals m, which we just found to be negative 6, x minus the x value that we had, which was 2. Okay. Let's distribute our negative 6. That becomes a negative 6x. Everybody agree at positive 12? And then when we add 1 to both sides, we end up with y equals negative 6x plus, and there's the equation of our tangent line of that h of x when x is equal to 2. Okay. So, y'all, before I go on to the next problem, I just want to kind of, because we've done this type of problem before. I know we haven't done it with this particular function, but we've found the equation of a tangent line before. So what I'm going to do over here, y'all, before I keep going, is just here on the side, okay, at some point x equals a. Okay. The one thing I would say is, number one, we need to know our point A and f of A, because that's going to tell me the x1 and the y1 part, right? So in the problem that we just got finished doing, and I'll go back to it in a second now, but if you notice, the first thing that I did before I went through and said, hey, let me find my derivative, is they told me when x is equal to 2, but I didn't know what the y value was. So the first thing we had to do is, since they told me x was 2, I needed to find the y value at that same spot. Okay, so we want to do that. Then number 2, what we'll do, number 2, then we want to find the derivative of our function, and we're going to evaluate it at whatever that value they gave us. Like in the problem we did before, they gave us at x equals 2. So we want to find the derivative, and once we find the derivative, we want to evaluate at 2. That's going to give us the slope of that tangent line, okay? Once we find the slope of that tangent line, number 3, use y minus y1 equals m times x minus x, okay? Solve it for y, and we found the equation of our tangent line, okay? So, y'all, just to give you a heads up, step number 2 is probably going to be the most, not going to be hard. It's just going to be the one that's probably going to take the most steps, because if you got to use a chain rule, it takes a little while to do the derivatives, right? Or if you have a quotient, you got to do the bottom times the root of the top minus the top. You got to do that kind of stuff. That's probably going to be the part that's going to take you the longest to do. But once you find you start off finding our point, and then you find the slope, then step number 3, I think, is a pretty straightforward step, right? Using that point slope. Okay. So I just kind of wanted to give you some general guidelines, I think. Again, we've done problems like this before, but I just want to make sure that everybody kind of understands this is kind of like the blueprint I should be following, all right? All right. So let me go ahead and go back, and let's take a look at the next one here. Okay, so we're combining the chain rule with other rules that we got, okay? So let's see if we can do this one here. So again, my function is h of x is equal to cosine of g of x. We don't know what g of x is equal to, okay? It's just some function. But we want to find the derivative of h. So we're going to say h prime of x, okay? First question, anybody know what the derivative of a cosine is? Negative sine, right? And in this case, it's going to be the negative sine of g of x, because that's what I have inside, okay? And then, y'all, we have to take the derivative of this piece here. Anybody know how do we write the derivative of g of x? Just g derivative of x, right? G prime of x. And that's it. That's all you're doing, right? Why? Because I don't know what g of x is equal to. But if we said, can we find the derivative of cosine of x squared? We could apply what we have right here, and we'd be able to do that, okay? So look, y'all, before I go on to anything else, I want to show you something. Suppose I said h of x is equal to the cosine of x squared, okay? Suppose I gave you this function here, and I said I want us to find h prime of x, okay? We said the derivative of a cosine is a negative sine of x squared, and then we have to take the derivative of what's inside. What's the derivative of x squared? 2x. Now I want to show you something. If you look at this piece here and this piece here, and you look at this piece here and that piece there, that's exactly what it's saying, right? Take the derivative of the cosine, which is a minus sign, leave whatever you have inside there alone, and then take the derivative of whatever we're defining as our angle. In this case, we said our angle was x squared, so the derivative of that was 2x. Okay. All right. So again, here's another problem. We're going to go through it slowly, one piece at a time. The first thing I'm going to do, y'all, I'm going to rewrite my function. I'm going to write it so that it looks like this. I know we talked about this one day, but I don't know if anybody remembers. Do you remember how we can write the square root as a power? Positive 1/2. It would be negative, John, if it was on the bottom. But you're right. The 1/2 is correct. Okay? So if I had one, suppose my function was 1 over the square root, then it would be a negative 1/2 because it was on the bottom. We picked it upstairs, so my side of my exponent changed. If it's just a regular square root, the power is 1/2. Okay? So y'all, we're going to find the derivative. We're going to find f prime of x. Remember, we bring the power down to the front, so that's a 1/2. And then we're going to rewrite this as 3x squared plus 4x plus 4. What do we do with our exponent? We subtract, so we brought the 1/2 down to the front, right? We subtract 1. Anybody know what's a half minus 1? Negative 1/2. Excellent. And then we still have to take the derivative of what's inside here. Okay? So let's take the derivative of what's inside there. The derivative of 3x squared is a 6x. The derivative of 4x is, and the derivative of 4 is, okay. So y'all, I'm just going to do a little cleaning up here. Okay. First question. Do you agree with me that this part can get kicked downstairs because the power is a negative 1/2? Wouldn't that just be the square root of 3x squared plus 4x plus 4? So this guy right here, y'all, got kicked to the bottom because it had a power of negative 1/2. Okay. All right. Second thing, do you see how this 2 is on the bottom? So I'm just going to put that 2 on the bottom right next to it. Okay. My question to you is, who would we still be left with on the top? Yeah, and just to give you just a general form, y'all, see how we have this 1 on the top over here for my 1/2? It would be 1 times that, which again is still 6x plus 4, right? I just wanted to mention the 1 to y'all because if that 1 was, say, a 3, I'd have to multiply it by this other piece right here. Okay? So here's my final answer, right? This is the one that's kind of cleaned up a little bit. Okay? Now, for the second part, we're going to find the derivative at 3. So again, all I'm really doing here, y'all, is just plugging in a 3 everywhere I have enough. Okay, so let me do the top. 6 times 3 is 18. 18 and 4 should give me 22 on the top. Okay. Let's see. 3 squared is 9, and 9 times 3 is 27. 4 times 3 is 12, plus 4. I'm just going to add those numbers together. I don't know what it is. 27 plus 12 plus 4 is 43. So on the bottom, I have 2 square root of 43. Okay. And next thing, you all agree that I can at least divide the 2 and the 22 out? And then one last question. Especially those of you who've had either trig or pre-cal recently, you remember how I get rid of the square root when it's on the bottom? Anybody remember? That we multiply by the square root of the bottom. Yeah. So we're gonna go like this. Look, square root of 43, square root of 43, right? So that gives me 11 square roots of 43. Now, y'all, again, when we multiply these two here, the square roots will cancel each other out, and that will just give me 43. Now, the reason why I was writing it that way, y'all, I'm not certain what my open math is going to ask you to do. Is it going to let you leave the square root on the bottom? If it does, then we would have been okay at this step here. If it tells you to rationalize, and I'm looking at the problem here, and it doesn't tell me anything about rationalizing my denominator, if it does tell me to rationalize, then I would do this. But this answer here, these two answers here, y'all, are really the same answer. It's just one of them is a little bit more simplified. This one over here, typically, we say is a little bit more simplified than this one here. They just, for whatever reason, somebody a long time ago said, we don't want square roots on the bottom. Yeah, I can't do much more with it than that, right? 43, I can't divide it out. I can't take square roots of it. So yeah, I'm gonna leave it like that. All right. So let's try this next one here. Go through again. Okay, so take a look here. It says use the chain rule to find the derivative of f of x equals 2 times 2x to the 10th minus 10x to the 5th, all raised to the power 14. Look at the directions. You do not need to expand out your answer. Okay, so we are not going to expand our answer. Well, I'll show you in a second. Okay, so first we're going to find our derivative. Everybody agree I'm going to leave that 2 that's in front of the expression alone? Okay, what are we going to do with the 14? Bring it to the front. So we got that 2 with the 14, and then we're going to leave everything inside alone, but we're going to subtract our power outside by 1. So that used to be 14, now we have a 13. Now, we still need to take the derivative of the top. I'm sorry, of the inside. What is the derivative of 2x to the 10th? 20x to the 9th, okay? Minus, what's the derivative of 10x to the 5th? 50x to the power 4. The only thing I would do here, y'all, is that. Yeah, I'd probably just leave it like this. If anything, I might distribute this 28 to those over there. You know what I mean? So I might say, look, what's 28 times, what is that? 20. 28 times 20 is 560. 560x to the 9th minus whatever 28 times 50 is. 1400x to the 4th. And all of that is still being multiplied by the 2x to the 10th minus 10x to the 5th, all raised to the power 13. So John, well, remember, you're multiplying the 28. You have like 1, 2, 3, right? So the 28 can get multiplied by these, but it's only going to get one of them, right? You're not going to multiply it by, you're not going to distribute the 28 inside there as well, right? It's like if you had 2 times 3 times 5, you would say, oh, 2 times 5 is 10, times 3 is 30, or you could say 2 times 3 is 6, times 5. You see what I mean? But yeah, you don't got to multiply by anything. So John, when you don't need to expand your answer, they're referring to that 2x to the 10th minus 10x to the 5 to the 13th. You don't need to worry about messing with all that stuff. You could. It'll still work. Okay. All right, so guys, I'm going to go ahead and scroll down to the next one. So again, look, Similar problem to what we did before. It says use the chain rule to find the derivative of f of x equals 4 times the square root of 5x to the 4th plus 4x to the 10th. So again, my first step would probably be, let me write it like this. 4, 5x to the 4th plus 4x to the 10th. What power? 1/2. Excellent. Okay. So now, when we find our first derivative, right, we're going to leave the 4 alone. But this power 1/2 is going to get multiplied by the front. And then we're going to leave what we have inside. And we have to subtract 1 from here. So what did y'all tell me 1/2 minus 1 was? Negative 1/2. Excellent. Okay. Now we have to take the derivative of what we have inside. Okay. So we're going to go through in pieces. Anybody know what's the derivative of 5x to the 4th? 20x to the 3rd. Excellent. Perfect. Plus, what's the derivative of 4x to the 10th? Power 9, right? Excellent. Good. Very good. Okay. Yes, 40. You're right. I'm sorry. My bad. Oops. Thank you. 40. There we go. I'm sorry? Power. What about it now? Okay, guys, right here, let me ask you a question. What's 4 times 1/2? 2. Okay, do you agree with me that that 2 is going to get multiplied by the 20x to the 3rd plus 40x to the 9th? And can we kick this guy down here to the bottom and write it like this? Would that work? And so the only thing I'm going to do, y'all, is I'm going to multiply the top part by the 2 all the way through. So that should give me something like a 40x cubed plus an 80x to the 9th. And now we're done. Good, very good. What do you think? You guys feeling okay about the chain rule so far? Not too rough? Good. If you guys are doing calculus already, nice. Week 5. Everything great. Good. Awesome. So let's take a look at the next one here. F of x. Remember, y'all, sine to the 5th x really means, again, I just really want to emphasize that everybody understands that that means sine x all raised to the 5th. Okay. It's just sometimes people think, oh, is it x to the 5th? No, it's just the trig function that's being raised to the 5th, not the angle itself. Okay. So when we find our first derivative, everybody agree it's going to look something like this, right? That part's going to come down. The 5 is going to come down. We're going to reduce it by a power of 1. Okay. Second question, y'all. What do we say the derivative of a sine was? Cosine of x, right? Okay. So all I'm going to do here, y'all, is I'm just going to write it like this. Sine to the 4th x, cosine of x. That right there, y'all, will be my answer for the first piece. 5 sine to the 4th x, cosine of x. Now, for the second part, y'all, since we're evaluating it at 2, and 2 is the real number, if I'm going to use my calculator, y'all, I really want to emphasize that my calculator needs to be in radians, okay? This is not 2 degrees. This is actually 2 radians. So when you have your calculator, if you go to mode, just make sure that you're in radians. So if you are in degrees, make sure you have it in radians. Okay. So this is what I'm going to do. I'm going to go 5 parentheses sine of, what do we say? Sine of what number? 2, right? And that whole thing is being raised to what power? To the 4th power. Okay? And then we're also multiplying it by the cosine of 2. And I'm just going to hit enter. And that's the value that I'm coming up with, right? Not a nice, pretty number. So I'm going to put something like negative 1.4225. If I were to say that I were to go to 4 decimal places, something like that, right? Now, guys, I'm going to ask you all a question because, I'm not keeping up with you guys. I'm not doing the homework myself. I'm doing them, but I'm not doing them. You know what I mean? I know. I would be failing this class. Guys, question. Have y'all had problems where you have to do like decimals in your answers?
Yeah.
Okay, does it tell you, like, if you were to, like, my question is,
It is not telling you.
okay, and is it giving you a thumbs up when you're doing it? Okay, that was my question. My question was, like, if you put 2, is that good enough? You know what I mean? If you rounded 2 decimal places, is it, like, I guess my question, like, she says she's been putting 2, and it's been working for her.
Well, like, for example, there was one yesterday where it's like, negative 0.3125, which is like 160. But I don't know if it's just based on looking at our calculator, because I didn't realize that was the whole number. So when I put 3.13, because I thought it was wrong, and I just said, okay, convert to fraction. And it gave me 116 to the data set.
Okay. Okay. All right. Yeah, I was just kind of curious as to when you're doing this, is it, I don't see anything specific about, round to so many decimal places, so I wasn't certain. Um, but anyway, just a question, Neil. Okay, let's see. Here we go. Okay, so y'all, now we're gonna do use chain rule with trig functions. Okay. So again, when we're doing the chain rule with trig functions, y'all, the way we're doing these here is the same kind of thing. So we have the derivative of sine of g of x. The derivative of sine is a cosine evaluated at that same value, but then we have to take the derivative of each of those angles as well, right? So look, I'm going to show you what I mean by this by doing this first problem here. It says if f of x equals 5 secant of 2x, let's find f prime of x. Okay, so look, if we were to find f prime of x, first thing is I'm going to leave the 5 alone because that's part of my problem, right? What's the derivative of a secant? Secant times what? Secant times tangent, right? So it's going to be secant of whatever we're taking the angle of, 2x, tangent of whatever our angle is, 2x, and then I want to show you something right here, y'all. Look at the one that I underlined. Do you see how it has g prime of x? The g prime is the angle on the inside, that's right. So what's the derivative of 2x? 2, okay? So right here, y'all, for my f prime of x, yes, well, let's see, I'm sorry. Yes, that's what we're going to do right now. So John says, look, y'all, we're going to multiply those two together. That's going to be 10 secant of 2x, tangent of 2x. Okay. Okay. Oh, right here. So we took the 5 and the 2 together? Yeah, and that's how we got the 10. So now we have 10 secant of 2x, tangent of 2x. Okay. No, that's what it is. Because I want you to look up here. John, if you look right here, you see how they wrote it? It's just secant and tangent. So you don't got to, those parts are already been simplified for you. Okay. Now you look, y'all, we're going to evaluate this at 2. Okay. So 10, now let me ask you a question, y'all. When you're doing this on your calculator, what's another way that we can write secant? Anybody remember secant is the same thing, 1 over what? 1 over cosine, right? So look, instead of me thinking about that as 2 times the secant of 2x, I'm going to think about the cosine of 2 times, in this case, 2, because that's the value we're plugging in, right? And then I'm going to leave that tangent of 2 times 2 alone. That's right. So when I look at, so if your calculator has a secant button, by all means do it, right? Mine doesn't, right? So look, this is how I'm going to do mine, y'all. I'm going to go 10, tangent of what number? 4, right? Everybody agree it's 4? Okay, divided by the cosine of 4 again. And then I'm going to hit enter. And I'm coming up with like a negative 17.7133. And that's probably where I would stop. I'd probably go to 4 decimal places, right? So negative 17.7133. And then you're done, right? John, can you do secant on your calculator? You can? Okay. So guys, I guess it all just depends on what kind of calculator you have. Here I'm sporting the TI 83 Plus straight out of 1997. So it just depends on what you have, right? John, what kind of calculator do you have, by the way, if you don't mind me asking? Okay, so John has the TI Inspire. So guys, if you have like a more modern calculator, you might be able to do this. And then I'm going to, I think I showed you guys before. I think I showed you guys on the first day that we were here. But in case I didn't, I'm going to do this real quick, y'all. Let me see. Okay, so let me try something real quick, y'all. I want everybody to be able to see this. All right, cool. We got a lot of folks here. Jennifer, Julio, Linder, Luciana, Matias, Uriel. Glad you guys are here. So guys, I'm just going to show you something real quick. I mean, I think at this point, y'all, I would recommend, if you don't have a calculator, if you're already in Calculus 1, I would probably get a calculator, right? But in case, funds are tight or whatever, so I'm sporting my iPad here. And guys, if you, I'll show you, I'll send you some pictures on Pronto. But you can get this on your iPhone. I have an iPhone, but if you have an Android, there's another app, basically the same kind of thing. But let's see, review. Okay, but I have this app here. It's called Graphing Calc 83, and I'll send you guys a picture of the little icon. But just so you can see what I'm looking at. Yeah. Okay, so you have Desmos. So if you look here, y'all, I'm trying to get this so it looks good enough. Okay, I know it's oh no, it's coming out okay, right? So this right here looks exactly like my calculator that I'm doing up here on the screen. I got the same buttons. And I think I've sent out videos before, and I think early in the semester, the first 2 weeks, I sent you one, and I was doing the y equals and then the y bars and all that kind of stuff. So anyway, something like this, y'all, on the App Store and for iPhone products or Apple products is $6. There is another one, and again, I'll send you guys a picture if you have an Android device, and it's called something like Calculate 84 or something like that. It's also $6, guys. So depending on what you have, if you don't have a TI something, but I'm sorry, you said you have what, Desmos? Is Desmos free? Okay. It's online? Okay, so Desmos is another one, you guys, and it's online and stuff. I'm familiar with the Graphing Calc 83 for the Apple products. I'm also familiar with the Calculate 84 for the Android. I'm not all that familiar with Desmos, but I know that it exists and it's out there. If you ask me a question like, how do I do this on Desmos? I might be able to answer. I may not. I'm not certain. But I can definitely do everything that the Graphing Calc 83 one has or the Calculate 84. So again, if funds are a little tight, those two apps cost $6, right? I know before the pandemic hit, when I was teaching statistics, I used the graphing calculator a lot because it has a lot of stats functions and stuff. I had students who went to like pawn shops and they bought an 84 for like $15. The only thing I would tell y'all is if you don't have a calculator, you guys, and you don't want to go spend $100, right? If you go to like pawn shops, take batteries with you so that you can make sure that it works. Sometimes they'll say, "Oh, this needs batteries," and then you get home and you put batteries and it still doesn't work, right? So if you need a calculator, that's something you can do. Some students bought it on like Let Go, stuff like that. You know what I mean? It's just, I mean, $100 is not chump change.
Also, very good video because newer ones you can't even have to take the battery.
There you go. Okay, so y'all, let's try this next one here. Again, I just wanted to kind of show you that, y'all, and I will send you guys, actually, you know what, let me do it real quick, because I'll probably forget. So let's see. Let me go to my Pronto app. This is us. Here we go. Boom, boom. Okay. This is the send for iOS. And okay, so they're being sent right now, y'all. I think the first one might have gone through, but you know, $5.99 either on Google Play or the App Store, but same kind of process. Okay? All right. So let's take a look at the next one here. It says f of x equals 1 over 2x plus 3. Find f prime of x. So again, y'all, when I'm doing this problem, I know I can probably do the idea of the bottom times the derivative of the top minus the top times the derivative of the bottom. And we got some birds going on out there, right? But I'm probably going to think of this problem like this: 2x plus 3. Everybody agree to the power? -1? Yeah, good. Okay, so let's go ahead and find our first derivative. So the first derivative is going to be -1 times 2x plus 3. Anybody know the power? -2x. Okay, and then we still got to take the derivative of what's inside. What's the derivative of 2x? 2. And the derivative of 3 is, so we don't need it, okay? So now our derivative, y'all, should look something like this. -1 times 2, -2 over 2x plus 3, all being squared. And it's just my email, y'all. Let me close that up real quickly. It does do that. Okay. Come back here. All right. So I'm going to ask y'all to do me a favor. Can you guys evaluate this at -2 and tell me what y'all come up with?
You know how d over dx represents derivative, right? Is d over d2 like the derivative of -2, right?
The way they would do that, John, is they would do it like this. So guys, John's question is, they use this notation a lot of times to find the derivative. So in this case, what we would do is we'd say, what's the derivative? This here is telling me, take the first derivative, which is what we got right here, okay? Now, John's question is, what kind of notation do they use when you're going to evaluate it at -2? They put a line right here, and they put x equals -2. And that's just like notation. So you're going to take the derivative, and then you're going to evaluate it at -2.
So then, okay, and then I think that's going to be the way it is was we do dx, and then it's like top right is like one derivative you want, and this is 20, like 20x 20, right? And then the top of it is b 20, like not even to the time.
Anybody come up with a value for f of -2? -2 itself? You got it, good. So if you notice right here, y'all, when you do 2 times -2, -4 plus 3 is -1, but when you square it, gives you 1. And so -2/1, +1. Excellent. Good. Very good. Okay. So here we go. We got another one. All right. It says, look, find y prime, then find the slope of the tangent line at 4 and 12/25, and round the slope and y-intercept to 3 decimal places. Okay, so we can probably do that. So again, y'all, just to give you a heads up, remember, that's my x1, that's my y1, right? Because that point is already given to us. So the first thing we're going to do, we're going to find y prime. So when we take the derivative, we should end up with 2x squared plus 4x plus 3. And if we reduce this to by a power of 1, it's the same thing, right? It's still, if there's an exponent there of 1, but we don't need to write it. Now we're going to multiply that by the derivative of the inside. So we got to take the derivative of what's inside here. So first question, what's the derivative of x squared? 2x. And the derivative of 4x is just 4. And the derivative of 3 was 0, right? So I might write my problem like this, y'all. Let's see. 2 times 2x plus 4 should be something like 4x plus 8 times x squared plus 4x plus 3. They didn't tell me that I needed to expand it, but they also didn't tell me that I shouldn't expand it. So I'm going to give you a heads up, y'all. This right here might possibly be good enough, okay? But if it is not, then I need to go ahead and expand it, okay? And, you know, I think our algebra skills over the last 4 weeks have probably gotten better. So if we were to expand it, let's just expand it just so that we know that we can. What's 4x times x squared? 4x to the third? Okay. 4x times another 4x? 16x squared? And then 4x times 3? 12x. Good. Okay. We're going to play this game again, y'all, but with the 8. So 8 times x squared is an 8x squared. 8 times 4x should give me a 32x. And 8 times 3 should give me a, there you go, 4x to the third. Let's see, 16 and 8 is 24 x squared. 12 and 32 should be something like 44x, right? And then finally a 24, right? Okay. All right. Now remember what we're going to do? We're going to evaluate this at x equals what number? What's the x value they give? At x equals 4, right? Okay, so let's find y prime at 4. Okay, so all we're doing is evaluating this now at 4. Okay, so I'm going to go 4 and then parentheses 4 to the third plus 24 times 4 squared plus 44 times 4 plus, what is that, 24. And I'm coming up with 840. What did we just find here? Anybody know? When we got that 840, what did we find? Okay, we found the derivative of the line at 4. What does that tell me, though, in terms of my tangent line? Anybody remember? That's their slope. Excellent. Good, y'all. That was my Valentine's present from you guys for me today. That's perfect. I'm glad you guys caught that. That's the slope. That's the slope. Yeah. When we take the derivative and we evaluate it. So look, I'm going to do this real quick. I'm going to scroll back up. We'll come back to our problem in a second, y'all. But I want to scroll back up to where we did one over here. So if you notice right here, this piece right here, when we find the derivative and we evaluate it, that gives us the slope of the tangent line, right? So yes, excellent, good, excellent, y'all. Really, really happy that we found the slope. And now look at step number 3. It says use y minus y1 equals m times x minus x1. Okay, so let's go back to our problem and scroll down wherever we were, which was over here. Okay, now that we have our slope, what we're going to do is we're going to go y minus, look up here, y'all, we wrote it up here at the top earlier. Y1 was 1225 equals m, which we just found to be 840 x minus 4. Okay. So this is y minus 1225 equals 8 times, or 840 times x is still 840x minus whatever 840 times 4 is, 3360. And then how do we get rid of our 1225? Add it to both sides. And negative 2135. Okay, so look, we found the equation of our line. We came up with y equals 840x minus 2135. Yeah, so for this part right here, y'all, this part here is just asking me what's the slope. And didn't we end up with an 840? Right? And then Johnson, since this is a minus 2135, we're going to put a minus 2135 up there. And we got it.
So, which one's going to be the beginning of the top?
Okay, that's what I said earlier, John. For the top box, John's question is, what should I be putting in right here? So, John, it didn't tell me that I needed to expand it out. So if I would try putting this one in first. And if it says that one up there is not good enough, then remember we expanded it and we came up with this piece right here. Then that would be the one you're going to put in. I don't necessarily know that it's going to, like we probably could have done this one here and we probably would have been okay. All we really did here is show off our algebra skills. Right? But that's pretty much it.
How do you get one?
Yeah. Union?
Yeah.
Yeah. Okay, so look, y'all, we're going to combine the chain rule with the product rule. Okay, so remember, I told y'all when we did the product rule, that one professor that I had back in the day, he'd always say, let's call this one the first function, let's call that one the second function. And the way we find the derivative of a product is we take the first function times the derivative of the second plus the second function times the derivative of the first. Okay. So let's see if we can do it this way. The first function I have, y'all, is 2x plus 1 to the fifth. So I'm going to leave that alone. 2x plus 1 to the fifth. Now I need to take the derivative of the second function. Let's take the derivative of 3x minus 2, all being raised to the 7th. Okay? How would I take the derivative of this guy right here? 7, and then what? Minus 2 to what power? To the 6th, and then there's still one more part. We got to take the derivative inside, which is 3. Excellent. Okay. Plus the second function, which is that 3x minus 2 to the 7th. Now we're going to take the derivative of the first one. Okay? So we're going to go slow here. The derivative of the first one. So we're going to bring down the 5. Then we're going to write 2x plus 1 to what power? To the 4th. And then we still have to take the derivative of whatever's inside. 2. Good. Okay. Guys, before we go on, are we okay in how we got to where we're at? Okay. Those of you at home, are we good here? So,
Yes,
Jennifer,
sir.
Julio. Okay.
Yeah.
Yes, Jennifer. Jennifer, you got a question?
Oh no, I was trying to. I was moving stuff. I don't know what I pressed. Sorry.
It's okay. That's okay. You just raised your hand. I just wanted to make sure we're good.
Yes, everything's
Matias,
good.
I'm sorry. Go ahead, Jennifer.
No. I'm just saying everything's perfect. Everything's good.
Okay. Matias, are we good?
Yeah, we're good, sir.
Okay, just checking with you guys. You guys, if y'all got questions, let me know. Remember, you guys are here too. Okay. All right. So let's take a look here. So look, y'all, I'm going to leave this 2x plus 1 to the 5th alone. I'm going to go ahead and put those guys together. That's going to give me a 21. I'll just move that 21 in the front. Okay. And then we have a 3x minus 2 to the 6th plus, let's see, over here, I'll put the 5 and 2 together. That's going to give me a 10. Let's see, this is 3x minus 2 to the 7th, and then a 2x plus 1 to the 4th. And that's probably all right there, y'all, I would do, just kind of fixing those pieces together. What's up, John?
They want to calculate the figure that various systems for different thing number regardless of the undistributed form versus distributed form.
That's right, because all it is just, if you were to, FOIL all that stuff out, or multiply all that stuff out, or factor some pieces, it's just another way of writing the problem, but it's still, the expression is still the same, right? Yeah.
So, doing that,
Uh-huh.
and another homework problem,
Uh-huh.
and it wasn't getting into the exact. I'm looking good.
Yeah, you probably made a computational error, but yes, it's still going to work out the same way. Okay, so look, y'all, we've done problems like this before. So look, first thing I'm going to do before I even start taking the square root, y'all agree with me that I could write this as 2x squared plus 3x plus 4. What exponent would I use? So I want you to notice I have a square root, but the square root is on the bottom. -1/2. Excellent. Very good. Perfect. Okay, so now look, let's find f prime of x. Okay, so we're going to take the derivative. So we're going to take our exponent, we're going to bring it down to the front. Then we're going to leave what we have indoors, 2x squared plus 3x plus 4. Now remember, y'all, from here, we have to subtract 1. So I'm going to think of that 1, y'all. Instead of as 1, I'm going to think about it as 2/2. Anybody know what's -1/2? Minus negative 3 halves. Okay? So that part we haven't really seen just yet, but it's okay. Now let's take the derivative of what we have indoors. So what's the derivative of 2x squared? 4x. Good. What's the derivative of 3x? 3. Okay. And the derivative of 4 is just 0, so we'll leave that part alone. Okay. F prime of x. Okay. So this negative 1 is on the top. So is that 4x plus 3. So I'm going to think of this like this. Negative and then 4x plus 3. Okay. Now this 2 is on the bottom because it was already on the bottom. So I'll leave it there. Okay. And let's see. We have this 2x squared plus 3x plus 4 to the power negative 3 halves. Let me show you guys how I'm going to write that. This is 2x squared plus 3x plus 4. Okay. So I want to show you guys how am I coming up with the square root of 2x squared plus 3x plus 4 to the third. Okay. So first off, you all agree that since this was negative, it was going to get kicked down to the bottom part? Okay, so that we understand the negative part. The negative part really doesn't, it makes sense. I think the part that I want us to make sure we really understand is the power of 3 halves. So guys, I'm just going to kind of do this on the side over here, just so that you know. When you have y to the power of 3 halves, what this means is we're taking the square root of y to the third, okay? And if you have something like y to the power of 5 halves, this means I'm taking the square root of y to the fifth. And I'm going to show you one more just in case we have, I don't think we have one like this, but I just want you to be aware. What would this mean? So I said we're taking the square root. Now, right here, y'all, on my square root symbol, we never write it, but there's an invisible 2 because it's the square root. So if I have something like this, what we're really taking now is the cubic root of y to the 7th, okay? So in general, y'all, I'm going to do this right here. It's like the general rule says if you have x to the power a over b, this is for taking the beef root of x to the power a. And you have two ways of writing it. You can write it like that, or you can write it like that. Where you put that power, you can either think of everything, like so if you were going to do this by evaluating, you could raise it to the power and then take, say, the square root, or you could take the square root and then raise it to the power. You would end up with the same thing, okay? Now, I don't necessarily expect you to have remembered this before today because it's probably a long time since you've ever seen this, but that's what the rule basically tells me. So that when I come back to the problem that I have, and I say, look, we have the negative 3 halves. So the negative part, this means we're going to kick it down to the bottom. The 2 here means I'm taking the square root. Again, we don't write the 2, but it's understood to be the square root. The exponent on top is the power on the outside. Now, guys, I want to emphasize everything in there has to be in parentheses because I'm raising that whole piece to the third. And that's how I would write my answer. Okay. All right. Okay, so let's see. We got another chain rule problem here. Let's go through it in pieces. Now, I'm just leaving the negative 1 on the outside, but if you want to write it as negative 4x minus 3, that's fine too. Yeah. Okay, so let's see if we can try this next one here, y'all. We're going to find y prime, right? Or dy dx. Remember, the dy dx, y'all, y prime, f prime of x, they're all just different names for the derivative, right? Okay, so remember, I'm going to leave that negative 2 alone. What's the derivative of a sine? Cosine of, in this case, 10x squared minus 4. You're good. You're good. Okay. Now, we still need to take the derivative of what we have inside. So what is the derivative of 10x squared? 20x. The derivative of minus 4 is 0, so we don't need it. So then our y prime would look like this. Negative 2 times 20x, negative 40 with an x, cosine of 10x squared minus 4. Okay. Yeah, that's fine. Brackets, parentheses, squigglies, whatever you want. Oh. It's just like the main, like what I really want to emphasize. Yeah, you're probably right. The way what I really want to emphasize is that's my angle, and that's not part of my angle. You see what I mean? So that's kind of the reason why sometimes I'll write brackets. It's just to let you know, like, hey, it's the cosine of 10x squared minus 4. So that 20x is not part of my angle. That was the derivative of my inside function. So I don't want to just, like sometimes, and I think this is a very good point, John, because I think of like if you guys say we're watching from home and for whatever reason the volume wasn't working, it would be real tempting to say, well, hey, why don't I multiply that 20 times this stuff here if it's right next to it? Because we understand that that's the derivative of the inside, and that's not, I'm not multiplying that by my, into my angle. So I think you have a very good point, John. Yeah, that's why I briefly do that a lot of times. Okay, that looks like it's it. That was the last problem. So y'all, just to give you a heads up, let me do this real quick. Okay, so when you click here, y'all, on your homework for 3.6, y'all, you basically got a week to get it done, right? So if I click on this here, I'm sorry. Uh, so actually, you know what? Let me do it this way, you guys. Let me come back here. Let me go to the student preview so that it can look like from your perspective. You know what? I haven't had a chance to look at it yet. The quiz. The quiz, yeah. Yeah. So guys, just to give you a heads up, let's see. Here we go. Okay. So if I click on homework 3.6, and you guys told me this is launch, I didn't know, and I hit start. Okay. So you can see the problems that I have here, y'all, should be similar problems to what we've done today in class. Okay. So there shouldn't be anything here that like, oh man, we didn't talk about this, we didn't talk about that, right? So like if I look at this problem here, hey, we did one like this today, except our numbers were like 4 and 1225 or something like that, right? We did one like this here too, right? So a lot of the problems that you're going to see here, y'all, should be something similar. I don't know, did we do this one? I don't think I did this one here. So I'll tell you what I'm going to do. Look, we're going to try this. We're going to go. So I'm going to pick this directly from the homework, y'all, because I don't think I did one like this. At least I don't remember doing one like this. But I will pick it right here. Okay, here we go. Yes, they're all just different ways of writing the derivative. I'm sorry, say that again? Well, because think about it this way. Why do we have g of x and h of x and r of x and c of x? I don't know. Same reason, right? Just let you know there's different functions, right? If we always use f of x, then when we have the composition, we can't really say, well, f of x equals this, and now f of x equals that, and find f of x, right? The same sort of idea here. Okay, look, y'all, so look, let's try this one here. And we may have done, but we probably did something like this similar before. So y prime. Okay, so remember, I have a quotient here. So y'all remember, if my function looks like this, And I'm going to take my derivative. It's always the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom. Very, very good, John. The bottom being squared. Okay, so let's take the derivative of this guy right here. Okay, what's the bottom? Anyone know? X to the fourth. Okay, now we're going to take the derivative of sine. What's the derivative of sine? Cosine x. Minus the top, sine of x. The derivative of the bottom. What's the derivative of x to the fourth? Anyone know? 4x to the third. Okay. All over the bottom function being what? There you go. Okay, so look, y'all. I'm going to write it like this. X to the fourth, cosine of x, minus, can I write it like this? And all I really did, y'all, is I just moved that 4x to the third. I just moved it up to the front so that it didn't look like I was going to write something like the sine of 4x to the fourth, like I wasn't going to multiply that 4x to the third to my angle. And so right here, I would say this is my final answer. X to the fourth minus cosine x minus 4x to the third sine x all over x to the eighth, right? And if I were to come back over here, y'all, I'm going to type that in right here. So let me get my fraction bar. X to the fourth. The derivative of sine x was a cosine x minus 4x to the third sine x all over x to the 8th. Okay. And does it tell me if I get it right or wrong right away? Chickadee check. All right, so far I'm sitting out of one, right? On the right track. Okay. So again, y'all, you can see again, the problems that you're going to see here, real similar to the ones we did today. Okay. Shouldn't be any questions in terms of like, hey, did we even do one like this? I mean, I'm not saying don't ask me questions, ask me questions. But what I really wanted to emphasize is that the questions you're going to see are questions that we talked about, right? Okay, so y'all, before we leave, I want to kind of give you a heads up of what we're going to be doing in the next couple of weeks. So right now we meet on Monday and Wednesday. We're in week 5. We got week 6. We got week 7. We got week 8. And you know what happens after week 8? This is what happens after week 8, and then we come back for week 9. Okay. And then we come back. We still got time. I'm just saying that spring break's coming up. Okay, that was the point that I was trying to make. So today, what did we do? We did 3.6, right? Was this 3 what we did today? Okay, 3.6. All right, just checking. Okay, yes. So Wednesday, y'all, we're gonna do 3.7, or was this 3.5? I forget. No, this is 3. Yeah, we're right. No, we're gonna take it beforehand. Okay. So this is kind of what I'm planning right now, y'all. Today we did 3.6. Wednesday we're going to do 3.7. Next Monday we'll do 3.8. The Wednesday after that we'll do 3.9. We'll probably throw in a quiz over chapter 3 somewhere in here as well. I'll probably open it up this day and it'll probably be due, or the Wednesday, you know what I mean? Because I give you a week to get everything done. You said, I mean, so like next Wednesday I'll open up the quiz on chapter 3 and it'll be due the week after that, right? So probably what we'll end up doing, y'all, is on this day, I'll probably teach you guys something a little bit new, okay? We might do something like that. 4.1, I don't know. I need to look at it yet. I haven't gotten that far in terms of my notes. I have all of this stuff done, but I haven't looked at chapter 4 yet. On this day, y'all, what we're going to do is we're going to review. So not this Wednesday, and not next Wednesday, but the Wednesday after that. So when would that be? Let's see. This Wednesday is the 16th. Next Wednesday is the 23rd. The Wednesday after that would be March 2nd. Okay. So I'm just going to give you a heads up. March.
So what is so the review going to be assigned on
Yes.
that Wednesday? Okay.
No. The review will be, I'll assign the review on this day. But on this day, I'll answer questions. Does that make sense? So I'm going to assign it in 2 Wednesdays, right? Not this Wednesday, but the following Wednesday, the review will be ready. And I'll assign it to you guys that day. A week later, I'm going to say, what do you want to know? Are there any questions in the review that you want to ask me, right? Okay. This will be test 1. Yeah, I'm not calling it a midterm, guys, because we're going to have test 1, test 2 in the final. So it's not, is it a midterm? Well, it happens in the middle of the semester, but it's not necessarily a midterm, right? It's going to be over chapters 2 and 3. We will probably do a little bit of something right here, not too much because it's the Wednesday before spring break, and then you get to go take the spring break. Now, guys, what I'm going to do for the test on this day, so this is going to be, if this is March 2nd, let me look at what that Monday would be, the 7th, okay? This is March 7th. What I'm going to do is test number 1 will actually be open. We get out of here at 3:50 p.m., right? I'm actually going to open up the test on March the 2nd at the end of class at 2:50. Okay, I'm going to open it up that day. It'll be due by the time we start class on, I guess this is going to be March 9th. What this is doing, y'all, this is an in-person class, right? We didn't sign up for an online class, we signed up for an in-person class. But some people feel better watching from home and don't want to come in because they don't want to get sick. I completely understand and respect that. What we're going to do this thing, guys, we're not going to have class. That's me giving you the day to take the test. You see what I mean? Now, I'm going to open it up the Wednesday before. So if you decide to take it earlier, hey, great, you take it earlier. But if you say my schedule is so busy that I don't really have time outside of class to sit there for, say, 2 hours or however long it takes me to take the test, me on March 7th, we're not meeting. That's me giving you the day to take the test. So if your schedule is that busy, then I say take the test on the 7th. Take it at 12:30. You just don't have to come over here to take it. Does that make sense?
Yeah.
Okay. So that's probably how we're going to work things out, y'all. So I will have the review ready for you guys. Not this Wednesday, but I'll have it ready for you next Wednesday. And next Wednesday, again, guys, I'll get a quiz for you guys as well. What I'm planning on doing is when y'all took the first quiz, the way my open math works, my open math allows me to make an assignment and it allows me to pick problems from previous assignments. So when I made the quiz for chapter 2, which is the only quiz you guys have taken, I was able to pick problems out of the homework that I gave you guys for 2-1, 2-2, so on and so forth. I'm going to do the same thing for the quiz from chapter 3. Now, when I make the review for the test, I'm going to be able to make the review going back and picking problems that I already gave you for homework in chapters 2 and in chapters 3. Does that make sense? So when you do your review, these are problems that you've already seen in your homework. Then when I make the test, I'm going to make this up. I have no idea how many questions I'm going to put in the review. Okay, I haven't even thought about it yet. When I make the review, I'm going to make this up. Suppose there's 30 questions on the review. Then I'll pick somewhere between 15 to 20 for the test, and there'll be those out of those same 30 questions. Now, will you get the same exact question? You might get a variation of it, but you'll get one of those questions. You know what I mean? So, like the problem that we did right now a little while ago was, I just did it. I don't know where I put it. Here we go. We did this problem here, right? Now, when you're taking, say, your quiz or whatever, your quiz may say find dy dx for, y equals cosine x of x to the 5th. But the principle is the same, right? Did the problem really change? No, because you know how to find the derivative of sine. I hope you know the derivative of cosine. And if you can find the derivative of x to the 4th, it's not a whole lot more to ask when you find the degree vector with this, right? So the problems are going to be, in essence, similar, right? They'll have some variations, but they'll be pretty much the same. That's how I'm planning on making the exam, okay? So anyway, just wanted to give you all a heads up of what we're going to be doing in the next few weeks. So again, y'all, next week on Wednesday, I'll have a quiz ready for you guys, and I'll also have the review for the test. And then the next week, we will do a little of chapter 4, just because I can't afford to, we still have to move forward a little bit. You know what I mean? We still got to do some stuff, but that stuff on chapter 4, you guys, will not be on this test. I just need to do a little something so that we kind of keep moving along, okay? Again, the one thing I really want to make sure, you guys, is that at the end of the semester, we're not like rushing through stuff just for the sake of filling up, of trying to get through everything. No homework spring break, guys. I mean, like, there'll be homework there, like, say, for 4.1 and 4.2, but, like, let's put it this way. When I cover 4.3, that homework will be due the Wednesday that we come back from spring break, right? It'll be open during spring break, but if you decided, John, that you want to do it that day, then you could get it done, right? You could do it before spring break, but it would be due, again, the week we come back. But again, it's not due. Let's put it this way. You won't have any homework due. You shouldn't have any homework due this day. Maybe you will. I don't know. We'll see. I'm trying to play it. I'm trying to give you enough time, right? So again, when I cover this stuff here, I'll probably make the homework for this due that Monday, and that Monday we come back. But again, you're going to have plenty of time to do it. So if you want to knock it out earlier, you're more than welcome to knock it out. Okay? I recorded it, by the way. Yeah. Okay, guys. So let me go ahead and stop recording. That's